Hi everyone, so, to begin, let's first draw any arbitrary angle BAC with angular equal to theta. We extend the base, AC, to some length. Now, taking A as the center, we draw an arc, of suitable radius, from B, intersecting AC, at D. Now, taking B as the compass marker point, and placing the needle end, somewhere, in the yellow region, we draw an arc, with the same radius, as before, intersecting AC, at E. The second arc should not be too far or too near the first arc. The second arc should also not be more than 90 degrees. We then find the midpoint of the arc, BD, by doing angle bisector, of the angle A, and mark the point, as alpha 0. On the second arc, BA, we make 3 equal cuts, from B, with compass, and name them as, beta 1, beta 2, and beta 3. Beta 3 could be above or below the baseline, but second one is a better option. We then find the midpoint of the arc B, beta 3. For that, we draw a line, from B, to beta 3, and draw, perpendicular bisector, of it. We then mark, the intersection point, of perpendicular bisector, and the arc, and label it beta 0. We, then draw an arc, taking a suitable radius, R, through the points, D, and beta 3. For this, we draw a line from D to beta 3 and draw a perpendicular bisector to it. We then take the radius R on compass and mark the center O on the perpendicular bisector. After this, we draw the arc passing through D and beta 3. Another way to draw an arc of radius R without so much constructions is to pre-make a semicircle of radius R with compass on a cardboard and cut it out. You can also use a protector for it. We then place the semicircle cutout such that its boundary touches the point D and beta 3 and draw the arc through D and beta 3. Then, in the same way, we draw an arc of the same radius R through midpoint alpha 0 and beta 0, intersecting the previous arc. We name the intersecting point as locus of trisection, or LOT. The arc can also be drawn with the semicircle cutout of radius R as before. Now, we draw an arc through beta 2 and LOT with the same radius R using compass or the semicircle. We mark the intersection point of this curve and the curve B, D, and name it A prime. We draw a line from A to A prime. The angle formed by A prime, A, and C is equal to 1/3 of the bigger angle BAC or theta. Now, in the same way, we draw another arc with the same radius R through beta 1 and LOT with the compass or the semicircle. We mark the intersection point of the two arcs as A double prime. We draw a line from A to A double prime. The angle formed shown here is again 1/3 of theta. The angle formed by B, A, and A double prime is also 1/3 of theta. This way, you trisect any acute angle with a straight edge and a compass with a very high degree of precision. To trisect an obtuse angle, halve the angle first to make it acute. Here, A prime AC is the halved or bisected angle of obtuse angle BAC. We then trisect the angle A prime AC using the method already discussed. Here, the angle A1 AC is 1/3 of the angle A prime AC. If we double the angle A1 AC, then the new angle A2 AC is 1/3 of the bigger obtuse angle. This is how we trisect an obtuse angle. To polysect an acute angle, such as quadrisect or heptasect, just increase the number of cuts in the second arc according to its dividing number, and carry out the same process as already discussed above.